My name is Hossein Pouresmaeeliasiabar, and I'm a master's student at ETS University under supervision of Professor Ali Motamedi. I'm here today to present our latest publication on acoustic comfort. So I start with this question: what is comfort? So I start with this question: what is comfort? From the literature, we can see that comfort is the state of being content in an environment. So if you feel happy in an environment, we call you comfortable. How many comfort types do we have? So we have comfort in terms of air quality. We have visual comfort, we have thermal comfort, and we have acoustic comfort. Today we are focusing on acoustic comfort. So what is acoustic? Acoustic is the study of sound. We are focusing on audible sound, which is the pressure wave from frequencies between 20 hertz up to 20 kilohertz. So, and why is it important to have the acoustic comfort analysis? It is important because it affects health, it can affect productivity in an environment, and it can affect other types of comfort. So how comfort can be measured? Usually, if you have the sound in an environment, you can have the characteristics of the sound wave, and you can apply some regulations on it, and you can say that it is comfortable to be in that room or not. But this can raise many issues because our auditory system does not work like that. Our auditory system is sensitive to some frequencies more than other frequencies. For example, you can hear sound frequencies from 4 kilohertz to 5 kilohertz louder than the others. Because of this, scientists introduced some parameters, we call them psycho-acoustic indicators, that can describe the sounds that and the feelings that the humans can better. So such as loudness, sharpness, roughness, etc. For example, roughness is the indicator that shows the feeling that you can have with hearing the sound R. It is called roughness. But having these psychoacoustic indicators can also can not be enough because, for example, if we have sounds like a jackhammer, if you don't know jackhammer, it's a device that you can dig the ground with the sound of ta 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 ta. This is jackhammer, and if you have, for example, heavy metal music or thrash metal music with a lot of drums, these two are very similar to each other. So how we can distinguish between these two? And also, I, as a fan of this kind of music, sometimes I like to hear this kind of music and sometimes I don't. So it depends on the mental state of the person. So we, based on these things, we propose something to add to those parameters. We add content type of the sound to those like parameters and apply those regulations on these parameters. And also we want to do all of these processes in a digital twin. So the idea is to have all of these like units to measure and calculate the indicators on an edge device and use that in digital twin. Based on this idea, we propose a framework, the classic 5-layer framework, um, starting with bottom of the slide. You have data acquisition layer, which receives the sound from the environment. You have the data processing layer after that, which measure the parameters of the sound wave and classify the sound. We have the data storage layer to save this information, the logic layer to do all the comparison, and you have the presentation layer to visualize all the information and process. With this framework, you will be able to predict the certain activities in an environment. You can identify unwanted noises in that environment. Also, you can alert the rooms in an environment which is louder than the others, and can bother other rooms, can alert them. To prove and to test the feasibility of this framework, we did an implementation in our lab. That is a big room which can be used, which is used in meetings, classes, gatherings, and etc. We also have a digital twin of this room on APS. We implemented this framework we implemented this framework in this room, and we merged the first layers, data acquisition layer and data processing layer on a Raspberry Pi using a electric microphone, and we used YAMNet model to classify the sound. YAMNet model is the sound event detection model that can classify the sound events into 521 classes, but we don't need all of those classes, so we categorize them into 5 classes. Then we have data, we use Azure MySQL database as the data storage layer, and we use Microsoft Power BI as the presentation layer to visualize the result. As you can see, this is the result of our implementation for a 7-hour period of time. As you can see, it is color-coded for every activity in the room. So the yellow color you can see in the left side is showing the meeting. Then you have silence in between from 2 o'clock until 4, 5 o'clock, and then from 5 to 7 you have another meeting. You also see you can see the sound pressure level with a line chart. You can see the middle of the graph. So using this framework, we were able to integrate sound, the acoustic comfort analyze system to an existing digital twin. In this system, we have privacy by design because all of the processes on sound are being done on an edge device, and you cannot receive the original sound from the database. And it can be considered as a scalable solution because you can have, if you have increase in the number of the rooms, you can add more edge devices and performance would not be decreased. In this implementation, we did not use, we use YAML model. Of course, you can use other models to classify the sound, and our focus was on the feasibility. So any performance tests were not done. And For future work, we are going to add some customized occupant-centric KPIs. We are going to test other sound event prediction models, and we can also use TDOA techniques to localize the sound source to have a better visualization of the comfort zones in an environment. And during the implementation, we had a lot of problems, facing a lot of problems using different microphones. And because the results are very sensitive to the choice of microphones, the number, and the location of. And the data sets for the sound events were limited. Here are the references that we have used, and thank you.